All right, section 6.4. All right, we already talked about these things yesterday, didn't we? But remember what I said yesterday? We were just doing an overview of them, but then we're going to get a little more specific about each of them. Well, that's today. We're going to get a little bit more specific about each of these things. The first one is the rectangle. So there's one special thing that we need to know about the rectangle. We already know a lot of things about the rectangle. What do we know? If I told you this is a rectangle, what could I mark on this thing? What could I tell you about it? Yeah, all four right angles. Okay, that's specific about a rectangle. What do we know about the opposite sides? So we know a rectangle is also a what? Parallelogram. No, a rectangle is not always a square. Okay, so it is a parallelogram though, right? So a parallelogram has what? Opposite sides are parallel and they're also equal to each other, congruent, right? So these opposite sides right here are parallel and congruent. These two sides right here are parallel and congruent. We also knew something about a diagonal, didn't we? On a parallelogram. What do we know about a diagonal? About the diagonals, I should say, on a parallelogram. What do? They bisect each other, exactly right. So I'm going to draw two diagonals. And let's put some letters in here. Call this A, B, C, D. Yep. We'll call this M in the middle. All right. So before today, what could I tell you about all these things? If I wanted to mark things equal to each other, I would say AB and CD are equal to each other. I would say BC and AD are equal to each other, correct? I would say they're also parallel. So AB and DC are parallel. BC and AD are also parallel. Yesterday, we also said that the diagonals of a parallelogram bisect each other. So that must mean that BM and DM are equal to each other, right? And AM and CM are equal to each other. So we know all that because of yesterday, right? But there's one thing that we didn't talk about yesterday on a rectangle that is true. And it's a theorem. All right, we're not going to prove the theorem today, but it is a theorem. And it says that the diagonals, right here, I've drawn two diagonals. The diagonals of this rectangle are congruent to each other. So we have a theorem. Oops. We have a theorem that says that the diagonals are congruent. I'll just say equal, okay? Is that all right? Again, a lot of geometry teachers would have a fit if I said equal because you're supposed to say congruent, but I don't know. It's just easier that way. When you say equal, it's supposed to talk about the measure of the sides or the measure of the angles. That's when you use equal. But if you just say the line segments themselves, you don't say line segments are equal to each other. You say line segments are congruent to each other. But it's such a subtle little thing. It doesn't really bother me one way or the other. Some teachers it does, all right? But it doesn't bother me. All right, so what's true about this? According to this theorem, what could I write down that's true? So the diagonals are equal, so let's write down in terms of our letters here. Yeah, AC, line segment. Let's do it like a regular geometry teacher would do it. Line segment AC is what? Congruent to line segment what? BD. All right? Now, is that true about every single parallelogram? No. It's only true about a what? About a rectangle. Would that be true about a square? Do the diagonals equal each other on a square? Yeah, why? Because a square is a rectangle, that's right. Okay, so I don't have to have another theorem that talks about the square and the diagonals being equal to each other. You see that? So you're not going to have a theorem that says that. All right, but you do have a theorem that says the rectangle, because every square is a rectangle. But is every rectangle a square? No. But every square is a rectangle. Excuse me. All right. So, all right, let's just do an example. I'll just use these same letters right here. So what if they tell you that AC is equal to 5x plus 2? and they tell you that BD is equal to 7x minus 6. And you want to find the lengths of both diagonals. Yeah, this is really simple. You've done this a million times, right? So what if you want to find the lengths of the diagonals? So I want you to find what the length, what the measure of AC actually is. And I also want you to find BD. So once I find AC, do I really have to do anything else to find BD? No, because they're the same. Okay, so you find one of them. So what do? Again, we've done this, not a million, but we've done this dozens of times, haven't we? Yes. So what do we do with those? Set them equal. I like to put the first one, or the biggest one, on the left-hand side. All right, so I subtract 5x from both sides. You can do that in your head. What do you get? 2x, correct? Add 6 to both sides. What do you get? 8. Divide by 2. What's x?
4.
X equals 4. Is that the question they're asking, though? No, what did I say? Find the lengths of the what? Diagonals. That's correct. All right, so let's find the lengths of diagonals. Let's find, I don't know, AC or BD. It doesn't matter. Which one do you want to put that 4 into? Let's put it into AC. It looks a little easier, right? Number's a little smaller, but either one's perfectly fine. So let's put it into AC. So what is AC equal? Now, notice I didn't put a line segment over top of it because I'm finding the measure of the angle, or not the angle, but the side, okay, the measure of the side. So I don't put the little line segment over top of each other, or on top of this. So it's 5 times x, which is what? 4. We just found that, and then plus 2. Everybody sees that. That's 20 plus 2 is 22. So AC is equal to 22. So what's BD equal to? Without doing any math at all, what's BD? It's also 22. If you wanted to, just to check, just to make sure it works, you could put the 4 in for this. So 7 times 4 is what? 7 4s, 28, minus 6 is 22. It works, doesn't it? Okay, all right, that was easy. So let's move on. Let's do another theorem. This time, so we're done with the rectangles. Now we're going to talk about, we're going to have a couple, let's see, 2. Yeah, 2 theorems about a rhombus. Okay, 2 theorems about a rhombus. So let's draw a rhombus. What do we know about a rhombus according to the definition? All the sides are equal, okay? Now, I don't know if this is drawn exactly right. I don't know. That pretty much looks like all the sides are equal, doesn't it? Okay. So let's do this. We're going to talk about diagonals again, okay? So a lot of this lesson is about the diagonals of these things because we know about the sides. We know about a lot of the angles, okay? We just haven't talked a whole lot about the diagonals. Now, the rhombus is still a parallelogram, agreed? So the diagonals still do what? What do we know right now before we even talk about this theorem? What do we already know about the diagonals of a rhombus? They bisect each other because it's a parallelogram, okay? And the diagonals of any parallelogram bisect each other. So let's draw some diagonals. All right. And I will call this ABCD. All right, and let's put some angles in here instead of putting a point in the middle and calling it like ADM or something like that. Let's just make it really easy for us. Let's just put some numbers in here. Wouldn't you agree it's a lot easier to name these angles if you stick a number in there? Yeah, so 3, 4. Actually, let me do it the way I have it in the notes so I don't get confused. This is 3 and 4. This is 5 and 6. This is 7 and 8. All right, so there we go. And you know it's a rhombus because you know all 4 sides are equal. Again, we're not gonna prove this theorem. You probably could, but we're not going to just for the sake of time. So it says each diagonal. This is the theorem. This is what we know about the theorem. Now, what do you think you're going to talk about? Do you think you're going to talk about the sides? Do you even think you're going to talk about the diagonals themselves? No, I numbered all the angles. Why do you think I numbered all the angles? Because I'm going to talk about the angles, okay? So we're going to talk about the angles here. So each diagonal of a rhombus, so let's just say this. Can somebody get the door? So the diagonals of a rhombus bisect. Now we already know that the diagonals bisect each other, but that's not what we're talking about. They bisect two opposite angles. So the opposite angles are being bisected is basically what it's saying. It's a little shorter way to say that. Okay? Everybody see that? The opposite angles are being bisected by those diagonals. So look, this angle right here is being bisected, and so is this angle. Now, remember what we knew about the opposite angles of any parallelogram? What was true about any opposite angles of a parallelogram? They're equal to each other. Excuse me. All right, so they are equal to each other. So, and they're also being bisected. So these two angles are being bisected. So what do I know about angle 1 and angle 2? If it's being bisected, say it. They're equal to each other. Okay, so angle 1 equals angle 2 because that angle right there is being bisected. Well, angle B is also being bisected. Angle B is also being bisected. But look, angle B and D are the same exact angles, right? So let's put a number in here. Let's say it was 60. So what's angle 1 and 2 if that whole big angle was 60? 30. Well, if this is 60, if big angle D is 60, then big angle B is also 60, and this is also being bisected, so 5 and 6 are also what? 30. So 1 equals 2 equals what? Equals, no. Just in general, because I just made up an angle there. Equals 5 equals what? Angle 6. Okay? This is only true about a what? A rhombus. And a rhombus is a quadrilateral with 4 equal sides. What else do you think is true about this? What else do you think I could say? Angle 3 equals angle 4 because it's being bisected. And angle 7 equals angle 8. But what's true about 3 and 4 and 7 and 8? They're equal to each other, right? All right, so this whole big angle A and this whole big angle C are equal to each other because they're opposite angles. And so 3 equals 4 equals 7. Oops, forgot the angle symbol. Equals 7 equals angle 8. All right, so that's what this theorem says, that the angles of a rhombus are being bisected. So tell me something about a square. Now, they don't put a theorem on here because a square is a rhombus. So they don't need a new theorem to talk about a square because you've already talked about the rhombus, okay? So tell me how many degrees, if I took a square and I drew the diagonals of the square, tell me each of the angles of those that are formed by those diagonals. 45, right, because it's a 90-degree angle, right? Because it's a square, and it's being bisected, right? You bisect the angle, the diagonals bisect the angle. So if you split 90 in half, that's 45. So every single time you draw the diagonals of any square, it doesn't matter how big it is, the angles are always going to be 45 degrees, all right? Now, a rhombus, it could be different angles here, all right? It just all depends. So you can't always say it's going to be 60 and this is going to be 30 and 30. You can't do that.
So in a rhombus, the total number of degrees is 360, right?
Correct. All right, one more thing. I'll tell you what, I'll just use this picture right here. One more thing about a rhombus. This is another theorem. It says the diagonals of a rhombus. Let's write that again. So the diagonals, they do something else too. The diagonals of a rhombus are, let's take a wild guess. Do you see where they intersect right here? What does it kind of look like is true about that angle? Looks like it's 90 degrees, doesn't it? And it is 90 degrees, all right? So the diagonals of a rhombus are, why did I put an E on the end of that? I'll blame it on my cold again. It's making me do weird things. The diagonals of a rhombus are what? What's the word if it makes a 90-degree angle? Perpendicular. Perpendicular. All right? So that's another thing we know about the diagonals of a rhombus, that they are perpendicular, which means we have, what kind of triangles do we have now? I got 4 what kind of triangles? Right triangles. I got 4 right triangles. Okay? So that could come in handy sometimes. Let's do an example with that. Let's just copy that. All right, let's draw the diagonals again. Come on. Here we go. So let's draw that diagonal. Let's draw that diagonal. Oh, sorry. It's probably really loud on the YouTube. Let's name it again, ABCD. And let's put some angles in here. Let's say that's angle 1. Let's say that's angle 3. This one's 2. This one's 4. And they tell you that this one is 34 degrees. That angle right there. All right? So here they're going to ask a bunch of stuff. Let's write down what they're going to ask, and then we'll figure it out. So they're going to ask for angle 1. This is part A. Part B is angle 2. Find angle 2. Part C, find angle BAD. That bad angle right there. Part D is find angle 3. Part E is find angle ABC. They should probably just tell you to find every single angle, right? Seems like that's what they're doing, but they are leaving out a couple. And then the last one, part F, is angle 4. All right, shouldn't be that hard. All right, let's start at the first one, angle 1. That should be super easy. No math involved, just looking at it. What is angle 1 equal to? Somebody tell me. This angle right here. What's this angle? It looks like it? Just because it looks like it? Well, first of all, I should have said this. Sorry. This is a rhombus. So it doesn't just look like a 90-degree angle. I don't want to go by that. It is a 90-degree angle. Why? Why is it a 90-degree angle? Not just because it looks like it. Because, that's right, because the diagonals of a rhombus are perpendicular. So it doesn't just look like a 90-degree angle. It absolutely 100% is a right angle. Okay, if this is a rhombus, if it's a rhombus, and these are diagonals, that angle right there is going to be 90 degrees. Okay, not just because it looks like it. How do I know that? Because we just did a theorem just 2 seconds ago, right? A little more than 2 seconds, but the diagonals of a rhombus are perpendicular. All right, let's keep going. Angle 2, that's this one right here. How do we find that angle? I'll give you a hint. We just talked about it just 5 minutes ago. Look. What's true about the diagonals of a rhombus? What do? They bisect the angles. Okay? So look at AC. That's a diagonal. What did it do to big angle C? It bisected it. So what's angle 2? It's going to also be 34 degrees. Okay? No math involved with both of those. You just have to know the theorem. We just went over them like 5 minutes ago. All right? Good thing we're doing the example, isn't it? Because that's why they give them to us. So that's also 34 degrees. All right, let's keep going. BAD, where's that? BAD, that's big angle A. That's that thing right there. Now we have to do a little math. It shouldn't be that hard. Do I know angle? Well, it asks, they should do this. They should ask for angle 3 first, don't you think? They don't. But anyway, 3 and like part C and part D, you can kind of figure them out at the same time. So what is angle 3 going to be? Okay. All right, so what's true about these two angles right here? They're being bisected. These two are being bisected. Remember we went through that whole thing? Look, we went that whole thing, right? 1 equals 2 equals 5 equals 6, right? In this one, it would be what? 3 equals 4 equals 7 equals 8. Do you see it here? Okay, so what's angle 3? 34 degrees. I'll just put a 4 right there. So what's this angle right here that I'm pointing at? It's also 34 degrees. So angle 3 is 34 degrees. What's big angle A? Angle BAD? 68 degrees. That's right. Just got to remember what's true about the rhombus, okay? It bisects the opposite angles, and we know the opposite angles are equal to each other. All right. We on the same page here? All right, ABC. ABC. That's this one right here. So how in the world do I find that? That one's a little trickier. I'll tell you what. Let's find angle 4 first. They should have asked you to find 4 before they asked you to find ABC, to tell you the truth. Let's find angle 4 first. How would I do that? I gave you a little hint earlier about that right angle. Remember I said you got 4 what? Right triangles. So this is a right triangle. So if that's a right angle, this has to be a right angle. This is a right triangle. Agreed? So how could I find angle 4? Okay, you could go 180 minus 90, but what's 180 minus 90 always going to be? It's always going to be 90. So anytime you have a right triangle, you don't have to go 180 minus 90 minus 34. You already know that these two angles add up to what? 90 degrees. Would you agree? But you are right. You're not wrong. I'm just showing you a little simplified way to do it. So all you have to do, what's the math? What's the only math you really have to do here? 90 what? Minus 34. That's what? 56? Is that right? So angle 4 is 56 degrees. 56 degrees. So what's this angle right here going to be? Now they ask you to find the whole ABC. They ask you to find this whole big angle right there. This is also 50. Well, angle 4 is 56. We already determined that. But the one right next to it, right, ABD, is also what? 56. So what do we get now? So ABC, well, angle 4 is 56. I'll put that right there. What's the whole big angle right here going to be? Just give me numbers. Give me numbers. Don't give me letters. What's the measure of it going to be? How many degrees is that whole big angle ABC? 112. How'd you get that? You add them up. That's right. 56 plus 56, and that's 112. So that's 112, and it's in degrees. Make sense? Okay. We only got 2 minutes left. I still got a few things to do. They're actually fairly short. So guess what I'm going to ask you to do tonight, besides just do your homework? Finish the rest of watching that lesson, okay? So go back, all right? Just showed you how to do that before we started today's lesson. Go back on the YouTube to last year's video, all right? Look at 6.5, and, just catch up after this right here. I'll tell you what, let's just do that really quick. Let's find it. I'll tell you what, let's do this first, because people on YouTube can't see what I'm doing, so I'm just going to close this out. So what's your homework? It's section 6.4. It's pages 272, 273, and 1 to 11. All right? So that's your homework for tonight.